Welcome back, guys, to this class. Let's look at Boyle's law. What really is Boyle's law? Right, so let's take a container, for instance, on your screen. Look at the container on your screen. You discover that as the pressure increases, as the pressure tends to increase, it's also showing the pressure gauge there. You discover that the volume decreases. Right, as the pressure is increasing, the volume of the container is decreasing. Right, provided that the temperature remains constant. And vice versa, as the pressure is reducing, you discover the volume is increasing. Right, the first time the pressure was increasing, the volume was decreasing, and it's vice versa. As the pressure reduces, what you discover? You discover the volume itself increase. That's what Boyle's law is in print. So what does Boyle's law state with that? Boyle's law states that provided the temperature or the mole of the substance remains constant, the pressure is inversely proportional to the volume. Right? It's very simple. In other words, what that simply means is that as the pressure is increasing, the volume decreases, like we saw in the video guide, right? And as the pressure reduces, the volume increases. So there are other ways we can state Boyle's law. We can use a pictorial example for it. I have a pictorial way of doing it. That let's take something like this. You discover that as the pressure is increasing, look at the pressure P. As it increases, right? As the pressure is increasing, right? You discover this, that as the pressure increases, that's the P. As it increases, the volume is decreasing. Look at the volume. V is decreasing. Right? As the pressure is increasing, the volume itself it's reducing. So this is just like a picture, something that can make you remember it, right? Graphically, you can also see that as the pressure against volume, as the pressure itself is reducing, you discover that the volume itself is increasing. Right? As the pressure is reducing, as it is reducing, what did you discover? Discover that the volume itself is increasing. That's what it means. So let's assume this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 atmosphere. And let's call this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cm cube. And let's call this Newton per meter square. Right? Let's just assume this. So as the pressure is reducing from 13, 12, 11, 10, 9, 10, as it is reducing, you discover that as it is reducing, the volume itself is increasing. Right? This is a pictorial excerpt for Boyle's law. Also, we also have another pictorial diagram that as the pressure is reducing, the volume itself. This is another diagram, right? This one is their inverse. With this now, they are proportional. Right, because we're already taking the inverse proportion. But that's that for just the graphical solution and something like a picture to make you understand. But then we have a mathematical representation of it. Mathematically, we know that the pressure is inversely proportional to its volume. Right, that's for Boyle's law, right? Provided that temperature remains constant, temperature or the mole, right? Temperature is constant, number of mole is constant of the substance, right? So this is what we have for that. Mathematically, what we do with proportional sign is that we introduce a constant. P becomes K over V, right? So if we make K over 1 and cross multiply, we will see that K will be equals to what? P times V. Right? What this simply means is that initial pressure times the final pressure is equal to what? Let's say initial pressure times the initial volume is equal to final pressure times final volume. Right? We can still say it's also equal to what? P3, V3, and so on and so forth, PN, VN, depending on what we are given. But naturally, we know this. In our physics and chemistry things, we know this, so we can apply this, right? So in the next video, we'll be treating questions as regards to Boyle's law to see how it works. I'll be giving you trick steps on how to know when to use when, right? When to use initial pressure and when to use the final pressure, when to use initial volume I'm going to use the final volume. I'll see you next video, guys. Thank you. Okay, let's look at question number 1 from Boyle. It said 325 centimeter cube of a gas has a pressure of, now look at, we are giving this as our first volume. Alright, so let's take parameters. Alright, parameters. So our volume 1 is giving us what? 325 centimeter cube of a gas has a pressure of 750. So we have our pressure, first pressure of what? 750 millimeter mercury. Right, what will be its volume? So we're looking for volume 2. We don't know its volume, final volume. Right, if the pressure is reduced to 600 millimeter mercury, so our P2 was reduced to 600 millimeter mercury, assuming that there is no change in temperature. So temperature is constant. Right, so this buttress, this looks like the Boyle's law, right? And I said mathematically, a Boyle's law, P1 V1 is equal to P2 V2, right? In this case, we're looking for volume 2, so we divide both sides by pressure 2 because we want volume 2 to stay alone, right? So what happens? P2 will take off P2 here. In that case, V2 becomes what? P1 V1 over P2. So what's our P1 there? First pressure is 750. So we have 750 times what's our V1? 325. 325 all over our P2. What's our pressure 2? 600 there. So P2 we have 600. Alright, 600. So a calculator, let's multiply. 750 times 325. What do we have? We have 243,750 over 600. So let's divide by 600 to see what we'll get. If we divide by 600, V2, that's our final volume, is going to be 406.25 centimeter cube. That's our answer. So you see that as the volume is increasing from this one, it's increasing to this. Right, look at our pressure 1. Pressure 1 reduces to what? To 600. Right, the volume here increased to what? 406.25. So that's just how it works. Right, look at it, very simple. Try and follow the steps. And then if there's any question, you leave your question in the comment section. Be sure to answer your question. Please do well to subscribe, right? Help us subscribe, share the video, like, comment, and that way it will help our community grow better. I'll see you in the next video, guys. Thank you.